So if I derive my position, what do I get for the derivative? 3t squared minus 42t plus 120. Good. Okay, so now it says when the velocity is 0. So how am I going to play that?
So you have to separate it into 2 different parts.
Okay, so I'm finding the zeros, right? So I'm setting the velocity equal to 0. So I'm going to set it equal to 0, and then I need to factor it in order to solve this. I notice immediately that there's a 3 that I can pull out of every term.
Oh, I didn't realize that. I just guessed.
Which is fine. So I'm going to pull that out. 42 divided by 3 is 14. And 120 divided by 3 is 40. So the 3 that's in the front is going to basically disappear because if I have 3 times the quantity, I can divide the 3 to the other side, right? If I divide 3 to the other side, what's 0 divided by 3? 0. So that 3 goes away. Okay. Now what two numbers multiply to 40 and add to negative 14?
10 and 4.
Okay. So t minus 10 and t minus 4. So the 2 spots when this function is stopped is at 10 seconds and at 4 seconds. Okay, but that's not the question. It says, what is the acceleration at that time? Okay, so how do I figure out acceleration? It's the derivative of your velocity equation. Okay, so here is my velocity equation. You see that v? So I need to go from there and derive that to get to my acceleration. Okay, so what is the derivative of 3t squared? 6t. And then derivative of negative 42t? Bless you. And then derivative of 120 makes 0. So now I can find the acceleration at the 2 spots that I'm looking for. So if I plug 4 in, so 24 minus 4 is... Wait, 42. Oh, I was like, what? What do you mean 42? Where are you getting 42 from? My bad. 42. I just didn't hit that. Okay, thank you. Gosh. Okay, that makes more sense. How about 24 minus 42? Negative 18. Oh, so that's what I did on that last one. So then if I plug 10 in, so 6 times 10 minus 42. So what'd you say? 18, positive 18. Okay, so we want to label this acceleration. How do we label acceleration? Meters per second squared. So those of you guys that were sitting with me earlier today, did you guys catch my mistake? I think I had a t squared in there. Let's see what I did. Where is that question? Oh, yeah, c my squared. That's what I did wrong. When I derived it, I was squaring things. So negative 18, positive 18. I'm glad we found that mistake.
You're in second period today, though.
Yeah, because I was doing it in that class earlier today when I was working with these people that came in. Okay. Question number 17.
Wait, 1 second.
Also, we can jump up to 16. Oh, wait, I have 16.
Am I going? Okay. Would you say 16 or 17? 17. Okay. 17. Okay, so this is a good one. Number 17, there's definitely more than one way that you can go about doing this. You can derive it as it's written and start by doing a product rule and do a first d second plus second d first, but when you go to do your d first, you have to use a quotient rule. I personally am going to simplify this before I derive it. It can actually be simplified very far, I guess you could say. Do you see how on this first term I have two numbers that are being divided by 7 theta? If you want to, by the way, change this theta to an x, if that makes you feel better, go ahead and do that. But remember that if I divide, I can divide each of these terms. So I'm going to have 1 over 7 theta. Okay, so 1 over 7 theta, by the way, is 1/7. I'm going to change this to an x. Is that all right? I feel like you guys are already doing that, so I'm just going to go with you to the negative first, right? So the x is coming up, so I can drive it. Okay, second term, I have 7 theta over 7 theta. What's 7 theta over 7 theta? 1, so plus 1. Okay, and then the second term looks fine. I'm just going to replace the theta with an x, so we're working with x's. Okay, so now I could go ahead and actually derive this and do a product rule. Or I could actually go even further and FOIL it, put it into standard form, and then do basic on it. You don't have to simplify to FOIL. Like FOIL to simplify, so that backwards. Yes, to make things easier, if you want.
Yeah.
So what do you guys want to do? Do you want to distribute this and do some algebra before we do our calculus, or do you want to go straight into the calculus and do the algebra last?
Let's just use calculus.
Go straight into the product rule?
Yeah.
Is that the easiest way?
I don't know.
You were doing this problem with
I did it this way before. I did product rule at this point.
Alright, let's do that.
Alright, let's do product rule. Here we go. Okay, so product rule is firsty second plus secondy first. Our R derivative. So our first stays the same, so I have 1/7 x to the negative 1 plus 1. What is my derivative of my second? Negative 1, good. Plus my second is 7 minus x, times the derivative of my first. What is the derivative of 1/7 x to the negative first power? Negative 1/7 x to the negative 2. And then, of course, the derivative of 1, 0 goes away. Okay, so now I do have to simplify this, okay? So I'm going to have to distribute the negative 1, this negative 1, through this quantity. So can I go ahead and distribute the negative 1 and also throw this x into the denominator? Do you follow that step?
Yeah.
So it'd be negative 1/7 x. Okay, now I have negative 1 times 1 minus 1. Okay, and now again I have this term being multiplied by my 7. Okay, so what is negative 1/7 times 7? Negative 1. And then I have negative 1x to the negative 2. 1 over x squared. Good. Everybody follow that? So the 7's like cancel, and I have an x to the negative 2, so I just stuffed it downstairs. Because you have 7 times 1/7. 7 sevenths. 7 on the top, 7 on the bottom. 7 times 1/7. Okay. 7 times. Okay, I have 7 times the negative 1/7, right?
Oh, I got you.
So that makes negative 7 over 7. Okay, so do you see how I have the x squared right here? X to the negative 2. I just shoved that into the bottom.
Oh, yeah.
Okay, now I have to multiply the next one. So I have negative x times negative 1/7 x to the negative 1. So if I have an x times x to the negative second, what do I do with my exponents? Add them. So how many x's am I going to have? 1 plus negative 2? Negative 1. So this is going to be plus 1 over 7x. Okay, my x to negative 1 I'm putting downstairs. Okay, so now do you see any terms that I can combine? Yeah, these two, right? The 1 over 7x's will cancel. We got one positive and one negative. So we can write this as 1 minus 1 over x squared.
Yeah.
16? Oh yeah, 16. No, 16, this one does have a little glitch in it because of the negative e. We didn't talk about this derivative. So number 16 requires you to do a product rule. Okay, you have a first, which is your 6x squared, and your second term is your e to the negative x. So I have to do which rule to derive this? A product rule. Okay, so this is a first d second plus second d first. Okay, so my first is 6x squared. Does anybody know the derivative of e to the negative x? It's negative e to the negative x. So now you know it's very close to it. Okay, plus my second e to the negative x d first. What's the derivative of 6x squared? 12x. So, for me to simplify this, I would probably just take this negative that's in the front and pull it or that's in the front of the e and pull it to the front of the term. So it's negative 6x squared e to the negative x. And then I would like to pull the 12x in front. That's not necessary to do. Can I combine those as like terms? Are they like terms?
No.
Yeah, because of the x being squared. So they're not like terms. We cannot combine them. Okay, one more. Pick a good one. 30. All right, so question number 30, it says the equation gives the position. So our S equation is our position of the body moving on the coordinate plane. Okay, so it says find the body's speed at time pi over 3. So how do you find speed? Okay, so it's the absolute value of your velocity. Okay, so all I have to do is find the velocity. So to find the velocity, I'm going to derive my position. So what is the derivative of 1 plus 9 cosines of t? Derivative of that is negative 9 sines of t, right? Because derivative of cosine is negative sine. Okay, so now I want to find the velocity at time pi over 3. So I'm now going to plug in the given time, pi over 3. Okay, so I hope you have a unit circle with you today. Okay, so on your unit circle, you need to go to pi over 3, which is right there. I think the ordered pair there is 1/2 and a square root of 3 over 2. Sine is referencing which one? The y. So my y there is the square root of 3 over 2. So now I'm just going to multiply 9 times the square root of 3 over 2, which makes negative 9 square root of 3 over 2. Okay, now if I want to tell you the speed, remember that this is the velocity. What is my speed going to be? Good. So my speed is 9 square root of 3 over 2. We want to make sure to label this. This is in meters in seconds, so how would we label speed? Meters per second. So please make sure to label your units on today's quiz. I will be looking for those. Maybe make a little note on yourself, like on your thing. Label units. Okay, are we ready? 28. 28 is exactly the same as this idea. Well, I mean, it's for the most part. A tangent, anytime they say tangent, you're finding the slope. Okay, so to find the slope, you just find the derivative, you plug in the x value. Okay, so find the derivative, plug in the x value. What did you say? 26? Okay, 26 you're just deriving. For 26, the first term requires a product rule. Okay, because you have two t's. Two variables are involved in the first term. So, my first is my t cubed, my second is my tangent, so it goes first. D second, what's the derivative of tangent? Secant squared, good. Plus my second, which is tangent, d first. What's the derivative of t to the third? 3t to the second. Okay, so now I also have to derive my last term. Remember, I have this minus square root of t, which is the same as what, by the way? Minus t to the 1/2. So what's the derivative of negative t to the 1/2? To the negative 1/2. Okay, and then I just simplify that. For this, there's really not much I can do. I have 3t secant squared. I would prefer to write the 3t squared in front of the tangent on the second term. And then the last term does require some simplification. We got to put that t down with the 2 in the denominator. But otherwise, that's it. Okay. '21. Okay, yeah. So to talk about 21, they're basically giving you 3 graphs. Okay, you have your position, then you have your velocity, which is the derivative of the position, and then the acceleration, which is the derivative of that. So remember that when you're working with a graph, you're analyzing the slope of each of them. Okay, so when I look at 3 different graphs personally, I say, okay, if I'm thinking about analyzing the slope of something, I want to find a maximum of some line, or a minimum. Okay, and of these 3 lines, the only one that looks to have a flat curve is this B curve. Okay, so right here at the very top of this, that has a slope of 0. So that tells me that the next function, the derivative of that, has to exist right at 0. Okay, so the only one that shows that is line C. Okay, and line C, notice that the slope of this curved B function is going down, right? And it's getting steeper and steeper. So this C function analyzes that perfectly. Okay, so my C is the derivative of my B. So now if I analyze my slope of C, this is a straight line. It has a constant slope. What would you estimate that slope to be? The slope of line C? Negative 1/2, 1/4, negative something. Okay, so the line that shows that constant slope is line A, right? This has a constant slope and it looks like it's at negative, I don't know, 1/2, whatever it happens to be. Okay, so B, this one is your position equation. Okay, the derivative of that was the straight line that went down, that was C, so that's your velocity. And A was your acceleration. Okay. All right, let's go over the answers here, because I want you to have time to finish this test. Okay, so we did a few of these together. Where did we leave off at? Do you guys remember? Number 9? Okay, so number 9, I don't know if we did number 9 or not, but number 9 is negative 8 over 169. Okay, number 10 is negative 12 over x cubed plus 42x squared minus 4. Number 11 is negative 2 over 5x to the third minus 1 over 3x squared. Make sure that you have that fully simplified. Okay, for number 12, you have a first d second plus second d first. Okay, so you can simplify this. I would accept a couple different scenarios. I did say you don't have to fully FOIL, so I would accept this first answer. You should at least distribute the 3. Okay, if you chose to fully FOIL and get standard form, you would get this answer down here.
Oh,
Okay. Question 13. This is kind of, I'm going to circle 13 here so you can see my work progressing. Number 13. Oh, wait, I didn't go that way. I went. So 13, I simplified the equation first and then I derived it. So I just rewrote 6 over x as 6x to the negative first. Same thing on that one. And then I actually noticed that these two were conjugates. So I FOILed them right away and said, oh, that would be way easier to just quickly FOIL that and then derive it from there. You can do a product rule. You should get to the same place. This should simplify to negative 72 over x cubed minus 2x. Yep. Okay, number 14 is a straight up quotient rule. There's nothing too tricky about that question. You should get 2x to the third minus 3x squared all over the quantity of x minus 1 squared. Yep, starts with the hoe. Okay, number 15. Oh, this one's not so fully simplified. So what I did for 15 is, this is me reducing the function. I haven't derived this yet, so this is not finished. So I said, well, this is going to be easier to just reduce this rather than do a quotient rule on it. So I'm simplifying each of these over x to the 1/2, subtracting their exponents. Let me zoom in a little for you. Okay, so now I just have left to derive this. So this is going to be 3/2 x to the 1/2, whoops, 1/2, plus 4x to the negative 1/2, minus 3/2 x to the negative 3/2. And then make sure to reduce your final answer. The right answer? I have it circled there. For, wait, 13? Oh, there you go. Negative 72 over x to the third minus 2x. Okay, 16, we just did that one together, and we did 17. Okay, number 18, make sure that you write down, if you didn't write this down already, displacement is the ending position minus the beginning position. Okay, so you're plugging those in and subtracting. In this scenario, both positions ended at 0, so your displacement is 0. Do remember, anytime you see the word average of anything, you are doing a y2 minus y1 over x2 minus x1. Okay, so that's going to be your displacement over time if you're working with velocity. So you get 0 minus 0 over 7 minus 0. The bottom says 7 minus 0. Oh wait, right here. Prepare 7 times 7 minus m squared. So I'm plugging it into the position equation. Okay, number 19. To find speed, we find the velocity and then make it absolute value. So we derive the first equation, so you get 14 plus 4, and then we plug in, it says at the end of the time interval, so the time interval is from 0 to 2, so 2 is the end of the time. So I would plug 2 into my velocity equation, which results in 12 meters per second. Second part of this question says find the acceleration. So to find acceleration, we derive velocity. So derivative of 4t plus 4 is 4. That is a constant velocity. I have nothing to plug it into. It's just going to be the answer. Okay. Make sure, again, to label your units. Label your units. Don't forget to label your units. Okay. For number 20, the greatest velocity is literally the furthest away, like above the x-axis. Okay, so you're looking at this point right here. and you're listing the y value. So that would just be 5. I should probably say 5. Yep. Good catch. What just happened? Yeah, right. Good call. I can't disagree. Alright, we just did, have we done all the rest of these together? Oh, no, wait.
No.
We did 21. This is your position.
Uh-oh.
Oh my gosh.
It's freaking out.
Velocity, acceleration. Come on, internet, you can do it. Push through. Okay, we did 22, right? Yeah, we did 22. 23. Anytime you're asked to find a direction that an object is moving, you're analyzing your velocity equation. Okay, so you're going to take your velocity, which in this case they give to you, and you set it equal to 0. Okay, setting it equal to 0 is telling you where the object is. Velocity is 0. Stopped. There it is. The object is stopped when the velocity is 0. Just seeing if you're thinking. Okay, so at 0, right? So it's stopped. So it's stopped on this one at time 7 and 1. So then we want to use a number line to figure out when the velocity is positive and when it's negative. So I choose a value within your interval, plug it into the velocity to make those decisions. This particular one is negative between 1 and 7. So that's where my time is moving, or my object is moving backwards. Okay. Okay, number 24. We have this ball that's being dropped off a cliff. It gives us a position function and says when does it hit the ground. Okay, so anytime we're asked when something hits the ground, we're analyzing the position being 0. So I start by taking position, setting it equal to 0. We solve. In this case, we got a plus or minus 6. But since we're analyzing a time, you can't go back in time and find 6 seconds. So we're only going to use the positive 6. Okay, so that's the first question. So 6 seconds for when it hit the ground. Second one is the ball's velocity at that moment. So I have to find the velocity. How do you find velocity? Drive the position. So I drive the position. I got negative 32t. And 6 seconds is the place I want to figure out the velocity at. So I plug that in and got negative 192 meters per second. Okay, for number 25, this question is, we got this runner, this guy's keeping a stopwatch on him, and it asks us, asks us to find the runner's average speed. So average speed, we're doing y2 minus y1, so in this case, the first 2 miles, we're going between 0 and 2. So you have 2 minus 0 over 20 minus 0 to get 0.0690 miles per minute. 26 we just did together. 27. Ooh, I haven't done 27 yet. How did you do 27? I'm going to have to bust this out really fast. First term, you're going to derive each term separately. I'm going to do a quotient rule on the first term, so it's going to go ho. D high, derivative of 10 makes 0, minus my high times the derivative of sine, cosine, all over my sine squared. On the other one, ho starts with a cotangent. D high, derivative of 1 is 0, minus my high times the derivative of cotangent. What's the derivative of cotangent? Negative cosecant squared, right? All over cotangent squared. So we basically get a negative cosine over sine squared. So it is possible to rewrite that in a different way if you chose to. It's not necessary. Second term should be minus a negative on top, so we get plus cosecant squared over cotangent. And again, you could rewrite this term in terms of sines and cosines if you wanted to. The 10. Oh, 10. Right there. Thank you. Very good catch. 10 minus 10 cosines. Thank you.
Where did the sign go?
Sine times 0.
Oh, right.
Same thing with this one. Right. Yep. Yep. Okay, number 28. Did we do this one? I can't remember. It's all blending together now. So 28, if they ask you to find a tangent, they're asking you to find the slope at the given spot. So we just derive it, plug in the pi over 4, and you should get a negative square root of 2 over 2. Make sure, again, you have your unit circle and you know how to use it. That is vital. 29. Okay, so 29. Good question. I like this question. Anytime they ask us to find a horizontal tangent, they're asking us, where is the slope 0? Okay, so for me to figure out where the slope is 0, I have to derive the function and set it equal to 0. So we derive the tangent of x minus 1, getting secant squared minus 1, set it equal to 0, and this requires you to remember how to solve a trigonometric equation. So we add 1, we take the square root, you get 1 plus or minus 1 is equal to the secant of x. I don't like working with secant, so I reciprocated it. The reciprocal of secant is cosine. I also had to reciprocate my 1s. Reciprocals of 1s are still 1. So now I'm using my unit circle, looking for where the x value is 1 or negative 1. And we should get 0 pi, I forgot my pi, is negative 1. And 2 pi. So 3 spots. And then we did 30 together, right? We just did that one. Yeah. Yep. All right, so make sure you pass those forward.